Hello everyone, my name is Ajay. I lead SDCore team at ONF. So today we have a presentation about SDCore 1.0 release and Aether 1.6 release. I shall be talking about SDCore release and later Scott will take you over the Aether release. Okay, so let's get started. And if you have any questions, just feel free to drop the questions over the Q&A channel and we shall answer all those questions at the end. Yeah. I'm sure most of you are already familiar with these block diagrams of the network functions in the 4G and 5G, but I just want to make a note here and start from where we are currently, right? So you see on the top side, there's all the 5G network functions, which currently we are supporting. And on the bottom side, you see the 4G network functions, which we have support, right? So, and in the middle, you see UPF. So our UPF is a common. It can handle both 4G as well as 5G, and it uses the PFCP to talk to control plane. Right? 5G project, we have taken the seed code from free 5GC, and we have numerous enhancement done on top of free 5GC code. And 4G code we have taken from ONF's own OMEG project, and we have enhanced it to make it more configurable, software defined. Right? So yeah, with these and all these network functions, what you see are the something which we are using in the currently in the Aether deployment. Aether is the our own network where it's deployed at multiple sites, and we do have end-to-end network, and we operate it, and we do get a lot of production issues, and that helps us to make our code more stable, right? Yeah, so let me just go over 1 minute. Yeah. So you can see that it says that we have like 4G support, 5G support, and 5G NSA. So we have enhanced OMEG project to support NSA at all the 5G, 4G network functions. So we have added all the changes, required changes. Yeah. 4G release, 4G code base is release 13 compliant, and we have taken selective changes from the further release, mainly around the NSA and around the PFCP protocol. So whatever really useful features from the new releases, we have gone ahead and implemented those features in 4G. And the same thing is true for the 5G. 5G code is a release 15.3 compliant. That's a base code, and we have added lots of improvement on top of it based on our need as an operator of the Aether deployments. All these network functions, what you see here on the screen, they are like containerized. We use Helm charts to deploy them on the Kubernetes. And as a part of release, we do publish Helm charts. So it's very easy to just take the Helm charts and just by running some Helm chart commands, you can instantiate all these network functions and start using them right away. So it's like very less issues in terms of starting using these network functions. So before we get into a lot more details about the 1.2 release, I would like to highlight the details what we have done as a part of 1.2, right? So we have been working on the SDCore, which is software defined core, for a long time, but we haven't had any formal release. And as a part of Aether, we have now a well-aligned roadmap for all, at least for next 2 releases, we have good roadmap. So we thought of following the proper process, so it gives a good idea about the all the ONF members and the rest of the community about the upcoming features and where we are going. So this release was made on the 3rd week of the December, and it's currently we run it on the Aether production. So one of the most important thing what we have done is that we have captured all the details into the documentation website. It has lots of details, like it has configuration guide, each and everything is explained, like the various options, how to use those options, and what is the impact of those options, of various options, right? Then we have, every time we make a release, we capture the Helm chart versions and corresponding image versions, so that members can just use the Helm chart commands with the specific version, and all the deployment comes in a few minutes. We have provided developer guide. Developer guide is something like if you want to contribute into SDCore, then you can use this developer guide to see how to take the code, how to compile it, how to start using it on a single machine, which we call it as a Aether in a box, where you can run all these network functions in the single node Kubernetes cluster and start doing your development. So that's the developer guide. Then we have the we have spent a lot more time on the 3GPP compliance because there are so many network functions in the 4G and 5G, and we keep getting a lot of questions about, do we support this feature, what release you support, and there are some high level feature supports, whether we have some feature supported or not supported or partially supported. All those things we have captured on the documentation side. So this is really mostly all the frequently asked questions we have captured in the compliance. And it really goes by service based, like what services our network functions are supporting and what services every network function is using, right? So, and as a matter of practice, like releasing the 1.0, we have released the notes which captures all the high level features, and it captures all the caveats of this release. All those things are captured, right? So when you get this PPT, you should have this access to these links and you can access these details. Okay, so one of the after documentation, the next immediate thing is that we have made life simple for anyone who wants to use 4G or 5G core, right? I mean, we don't want the like operator to go at n number of network functions and configure them individually. It's not something which is practical, and it's error prone. So what we have done is that we have provided a simple APIs, configuration APIs, and those APIs are common for 4G and 5G. So you just fire those APIs, and those APIs are we have aligned or abstracted around the network slice. So we just say enable this network slice or create this network slice or delete this network slice, right? And we handle all those complexity behind the scene and configuring all the individual network functions, passing the right configuration to every network functions. And if there's any network function restart, then making sure that the whole configuration again goes to the newly restarted network function. So everything is handled under this API. So literally it's just configuring one API and you're done. So no understanding of whole 3GPP is required. Then we have our next focus is that we want to see that how enterprise can use our solutions and provide some good use cases. So we have, at least as a part of 1.0 release, we have done two solutions. One is like application filtering, where like isolating or restricting the access of application to specific slice and giving the QoS, like you have the QoS at the slice level QoS, you have user level QoS, and you have per application QoS, and we implemented the QoS metering for the same. And we have this 5G stable version available and deployed on the Ethernet network now. So that's the first time we have made it available. And for all this to happen, we need a good simulator. So we have developed our own GNodeB simulator, which is used for the 5G testing. And so this is very high level things for 1.0 release. So probably we can see how we deploy typically Aether, right? You may see the central cloud where we deploy the control plane, and then at the multiple edges you have this UPF deployed, right? So first of all, you can deploy this control plane anywhere. It's not mandatory to have this control plane only in the cloud somewhere in the central location. If you have use case, you can decide to deploy it at the edge. If you have those resources, if you have Kubernetes cluster, you can go ahead and just use those Helm charts and deploy it at edge. So you can see that it's possible to have it at edge also, and we are planning to release those versions as well. Each site can have its own one or more UPF. And I think in the next further slides, we can see that what are the different options we have on under the UPF. So what we do is that we have one UPF per slice, right? So if some enterprise wants to create more slices, they configure multiple UPF, right? And that's how you have this multiple UPF shown in the edges. So all this, you can see that they are like control plane, user plane, they are not close, right? They may be like far away. And we follow 3GPP's CUPS compliant implementation. We use PFCP protocol to configure the user plane. And naturally, since it's not closely located, we do see a lot of issues which are must to have in our code. We have to handle these error cases where some timeout happens, and you may not, you may see multiple messages coming in, like retransmitted messages coming in, right? So we have to handle these error cases. So made sure that whatever was base code, we have improved it in a way that it seamlessly work and it handles all these error cases, which is typically seen when you have deployment with the multiple sites. Yeah, and of course, since you have multiple edges, you can always add or delete UPF at any time. You can take out edge at any time. It doesn't have any impact on the central control plane. Yeah. Yeah, and this one is important. Like, since you have so many edges, we don't mandate that all these UPFs have to run on the same version. Right? So there's always a chance that during transient time, you may have different versions of UPF running and talking to the same control plane. And you can see that we have this both control plane at the central cloud. It can be 4G, it can be 5G, or it can be both. It really depends on what use case or what is the edge network you have, what kind of radio network you have available. Yeah. Okay. So now going back here, so we have two UPFs available. One is like base UPF, which is software switch based UPF, and other is a P4 UPF. So UPF is covered as a part of our SD Fabric project, ONF's SD Fabric project. Base UPF typically we use when you need throughput of 100 Gbps or something. And since it is a software based, it can be very well deployed in somewhere in the cloud, right? If you don't have any stringent requirement on the latency, you can decide to deploy it in the cloud. So we had done some of the deployment that way, where like control plane as well as UPF, everything in the cloud, and we are just carrying out some POC where someone comes up with their radio and they connect it to your control plane as well as UPF in the cloud, right? So it's very easy to have this kind of POC. You don't need to spend days and days to get this deployment ready and get those things tested. So it's very easy for us to do that. At the same time, we have this P4 UPF, which is a hardware-based UPF, but that's designed for like throughput in the terabytes per second. And so enterprise gets option of choosing between the base and P4. That really depends on what's their use case and what kind of throughput or latency requirement they have. And you can, of course, you can have mix and match. You can have like one or two P4 switches, one or two P4 UPF, and multiple of base UPF running at the edge side. That's possible. And single control plane can talk to multiple of these UPF and install write session into write UPF, right? And the natural question comes around like how we select UPF, right? Fortunately, in the 5G, you have the options of like slice IDs and DNN and all those things. In 4G, we don't have all those things. So what we have done is that in the 4G, we do the APN-based selection at the UPF selection, or we do location-based UPF selection, right? And you can imagine this configuration operator never says that, okay, if the user is coming, then you select this UPF, right? All these things are happening just through the network slicing APIs, right? So we take care of configuring the right set of network functions. We do have this IP address allocation supported at both control plane as well as at the UPF. Then miscellaneous features like doing the PFCP path health check using the PFCP echo. Then we have UPF initiated associations. We have UPF initiated session reports, that's to handle to send the reports about the downlink data. So all these features are available. So there are a lot more things. UPF, since it is part of SD Fabric project, it's not just UPF. It comes with a lot of more extra infrastructure support and with redundancies and all. So SD Fabric project is has a lot more details, and they have some past Techinars also, which talks in more depth about how these UPFs are realized. Right? I encourage to go through this link, and there's a SD Fabric project link which you can go through, and you will get a lot more details about the UPF. Okay, now coming back to the how SDCore looks like. So typically we have things very much clear in our mind, is that nobody needs to know what's there under the SDCore, right? So we just give so everything is API based. So you want to configure slice, we have one endpoint where you just configure the slice. You want to configure subscribers, which is like provisioning the subscribers either in the HSS in case of 4G, or maybe UDM or UDR in case of 5G. We just provide the APIs, and we take care of pushing the data to the right network functions, right? So one of the unique thing here is that we have taken out this whole SIM thing out, and we have provided the subscribe provisioning APIs. We have ambition of bringing in the third-party applications with the SIM management platform, and they configure the SIMs in the SDCore, right? So typically this is a very separate work. As such, it has nothing to do with the 3GPP's network function usage. So we have extracted this out, and what we get is just the SIM card information, which we push into the right network functions. Then second part of the configuration is the slicing configuration. Like, given a use case, we want to enable that slice in the 4G or 5G network functions, and we get enough details from that slice, and we just enable that slice so that operator can readily connect their eNode B or gNode Bs, and they can just start making use of that slice for their use case, right? So, and third thing what you see is that, okay, so of course we have this add, update, and remove kind of APIs. APIs are same for 4G and 5G. As usual, UPFs can attach and go. So there's one thing is that currently we do provide these UPFs pool when we start enterprise network. We create some upfront some UPFs, right? Software based UPF. So we have some plans which is in progress, is that when you really create the slice, it should instantiate the UPF at the edge, the appropriate edge, right? Those things are in progress. That's still not part of this release. So currently in this release, what we say is that enterprise should create those UPF pools, and then, you know, based on their need, and then use those UPFs in some slices. And so, and of course, slice selection, we do slice selection selects one of the UPF as a part of call flow. You see, like the statistics come out of UPF as well as the SDCore, they are pushed to the Prometheus. And we do have some dashboards, Grafana and Aether portal, which shows those dashboards with nice graphics. I think Scott is going to cover that portion in his slides. Okay, so the design what we have is that it's very high level. It's like this configuration endpoints land on the one of the pod, and then that pods take care of pushing the required config into the multiple microservices, right? So it's a single endpoint which sends the configuration to multiple microservices. So these the one of the advantage of this is that we don't have to we don't say that SDCore works only with Aether. If somebody wants to use SDCore and they want to have their own portal and they want to call this API, that's perfectly fine. They can do that, right? That's the beauty of having the clear separation of these modules. So yeah, we take care of distributing the configuration to 4G and 5G, all the appropriate network functions. And then this config server that detects the new microservices. So it's not like somebody has to tell config server how many microservices are running and all. It's not required. So there's a service discovery and there's automatic config push. All those things happen. So the admin need not worry about pushing the config again. If there is some fault at the SDCore, it's not required. So we do have slice deletion support. So we appropriately release the PFCP connections and we remove the UPF from the slice. We release the subscribers which were associated with those slice. Right? Yeah, I think this is what I was telling, is that we have ambition of bringing in the real third-party SIM provisioning application talking to SDCore. But while that's not in place, what we have is that we have developed our own application here, which is completely separate. It gets deployed separately, and then that gets the details of the multiple SIM cards, and we configure it in the SDCore. So that's what we have developed currently. Yeah. Okay, so this goes in a little bit more details about what do we do. So this left side thing shows that you have multiple subscribers. They have assigned to different inode Vs or gnode Vs, and then we have these logical slices where we configure the applications, and then we give the access to application to certain slices, right? And this, of course, like enterprise may have certain applications which needs to be accessed only by certain endpoints, right? So those details we configure as a slice APIs. So behind the scene, what really happens is that this is like I have shown the 4G picture, but that's equally true for 5G, that this configuration is actually pushed, like this, all the application filters, they're already pushed to PCRF, and PCRF is the one, or PCF in case of 5G, they're the one who creates the rules based on the configuration, and then that those rules are pushed to the control plane, which is either SMF or SP gateway. And we form the PFCP message, which is like, it goes under the PDRs and FARs and QVRs, right? So you see, like, operator doesn't know all these, like what is a PCRF rule, what is PCC rule, or what is session rule in case of 5G, right? They don't need to worry about all these things. What they configure here is that in this slice, I want to allow application, this application at whatever QoS they configure, right? And this slice, I want to allow this application with this QoS, and we take all these things under the hood and we configure it. So it's really a plug and play. You just configure it and you just start accessing it, right? And you can see here that radio resources as of today, they are shared. Our SDRAN project, the work is in progress when we bring in the ORAN compliant SDRAN, and that's where you will have a lot more slice intelligence within the RAN as well. As of today, whatever radio we are using in Aether network, that is not SDRAN compliant. But we do have some kind of trials happen where SDRAN compliant RAN was used to talk to SDCore. Yeah, this was a very much important. This isolation was a very much important for the enterprises. PCRF/PCF, they generate the policies, and we use the flow gate, right, to decide whether the application is allowed or not allowed. There's other option of using the FAR rules, which is a forwarding rules, to configure whether forwarding is dropped or not. So there you have options. PFCP is a lot more flexible, and we are using the QoS gate as an option to allow or deny the traffic, right? Then there's a slice level QoS. While you're configuring these slices, you have multiple users accessing through the slice. So we want to limit the bandwidth given to a specific slice, right? So that's a slice level QoS. So this is not something which comes from the standard, but this is something which is very much required practically, right? So yeah, I think this is what. Yeah, so we use all the PFCP flexibility to configure UPF. Okay, so as I said, like we have taken free 5GC 305 version. What changes we have done? First of all, configuration APIs were not present in the free 5GC, so we added that. Like most of the open source project, if you see, they are like, you have fixed config, you start the network function, it works well. But if you tell them to change some configuration, then they ask you to restart your network function. That's not something feasible. You cannot restart the network functions for every small addition of configuration, right? So that's the reason we have our since we use these in our real network, we know that these are the problems which our code should handle. So we have made it configurable. So to start with, this is a reliable output we get, like 5,000 subscriber, 10 calls per second, and it's like single instance and it works well. So our plan is to go up to 8,000 with the 50 calls per second with the single instance, and that's the limit for single instance with the current set of resources assigned, and then we'll go for the horizontal scaling, right? So we had done numerous changes to even reach to this limit. So there are a lot of improvement in the code which was required to, otherwise it was not scaling up. So, and while we were using this 5G and 4G code in the multiple trials, we had found a lot of issues which really come up in the practical network. And they were about the UPF connectivity, like UPFs are coming up, going down, or not responding, or packet drop. All those issues we have resolved. There are numerous issues. So we have handled all the cases where you are free to restart any network functions at any time, and you shouldn't see any impact in terms of handling the new calls, right? So there are a lot of dependencies. We have got rid of all the dependencies across the network function. So it's not like to start AMF, I need SMF to be present again, SMF to be already running. No, or NRF to be already running. No, we have made sure that we have enough number of like code handling to make sure that if some network function is not available, it can have the retry, or it can try after some time, like maybe in the when there's a new call comes, that time it can go to the NRF. So all those required practical changes were done. And of course, everything is asynchronous. We don't get blocked on the, like something is not working, we don't get stuck at that place. So we had issues on the NGApp interface and N1 interface. So this one we saw in the SDRAN trial when we got three new phones, and every phone has a different behavior. And we had seen that some of the messages are not coming up, or some of the messages are getting retransmitted from the mobile, right? So we have added those fixes in the SMF as well as AMF to make it more stable. And of course, it's like 100+ commits to get this code stability. And we have added the compliance document in the SDCore documentation set. So that's really handy for us to know where we stand in terms of the current 5G support. So yeah, it's available on the Aether network. Currently, we do have two edges, FET and entity. They connect to the central control plane with their 5G edge. We are evaluating the radio at our main office. And once that's done, we will be also moving to the 5G. Yeah. Yeah, as I said, like in the SDRAN trial, we have these two network slices with the 5G, and we have tested it with the ORAN compliant 5G core. So I'd like to go through this GNodeBees SIM. So if you see this box, it has like SDCore and multiple UPF, and you may have multiple applications deployed. What we have is that this is the one box simulator instance. It simulates UE plus GNodeBees. Okay, first of all, then it is containerized, so it's very easy. You just take the image and you just instantiate it wherever you want to start, right? And the very basic configuration it asks you is that where is AMF, where I should connect, right? And maybe some subscribers for which you want to try out some various 3GPP procedures. You can, since it is containerized, you can run multiple instances of it without any issue. So this is very much a differentiating factor. We have not designed it only for developers. We have designed it for the automation. So when you run something, we don't want somebody to go through logs and figure it out, or what happened to my test case, right? So we give enough data for the automation so that they can conclude it easily whether the test case passed or failed, or whatever, for what reason it failed, right? So that's to make sure that automation is like runs reliably, and at the same time, we as a developer, we don't have to we have enough freedom of changing our logs or changing our stats, because automation is not going to depend on those logs and stats, right? They will get their own summary results separately, right? So we have designed it for automation. So as of today, we have inbuilt sanity traffic test. So we when UE is completely connected to the network, we generate our traffic and we test that call has gone through. But our intention is that in 1.1 release, which is coming up in the next 2 months, is that provide the interfaces, traffic interfaces, so that external traffic generator can be used, and you can have various different type of traffic generated. So as of today, we have these many procedures supported, and the like couple of things are in plan which will happen in the upcoming release, right? So and how to use the Genode SIM and everything, all those documentation and its design things available in the GitHub and as well as SDCore documentation website. So this wraps up my thing, but I'll just quickly tell us like what we are doing currently in the 1.1 release, which is supposed to get delivered in the Q1 of 2022. So one of the thing which we are planning to do is that adding a lot more 5G QoS call flows, right? Based around the enterprise use cases. So like whatever we just saw for 4G, similar thing for 5G and lot more things, right? So, and we want to delete the subscribers gracefully if there's any kind of operation and maintenance of operation is done by the admin, then we want to instantly delete the subscribers. Then we have cloud native architecture ready, and we have some steps identified for that. So when I say cloud native, that really means a lot more, and it's not something which is going to happen in like one release or maybe 2-3 months, right? So we have identified all the steps what we have to do, and we have started doing the prototype. So we should be having this prototype available as a part of release in the 1.1. We have some new Genode simulator enhancements planned, which definitely includes the handover and paging support, and as well as traffic support, whatever I talked about. So we have agreed on paper about how dedicated bearer APIs will look like, and that's what will get implemented partially in this release, and maybe it will be available in the further release. Yeah, one of the important thing we have identified is that there are a lot more microservices. Everyone is giving out so many metrics, and it's very difficult for operations team to get the sense out of it. Right? So as a part of SDCore team, we are enhancing our metric design, and we are prototyping those things. So the first version of that should be available in this upcoming release. So which will like, as usual, it will make sure that inside the box, we will do all the magic, and we'll just give away metrics which are really useful for the operator. Yeah. And these are various resources. We have a homepage, we have white paper, we have wiki and release notes and 2021 review blog. And first of all, there is a community Slack. Anyone is free to join that community Slack, and feel free to ask the questions if you have any. Yeah, that's wrap up from my side. I'll just hand it over to Scott. Scott, over to you.
Yeah, thank you, AJ. Let me get started here. I'm going to take over the screen share. Okay, so my name is Scott Baker, and I'm the Aether Operations Team Lead. Next, we're going to be talking about how ONF takes the SDCore components that AJ presented and builds it out into a complete managed edge connectivity solution. ONF's solution is built onto 3 primary pillars: SDCore, which you have just heard about, SD Fabric, which is our edge fabric solution, and SD-RAN, which is our radio area network solution. Our current deployments do not fully realize the SD-RAN component at this time, but we have done a trial with Deutsche Telekom, and if people are interested, I can provide a link to some information on that trial. At the top, we have some management components. So we have our runtime operational control, and on top of that, we run some portals. We have an operator portal and an enterprise portal. And then we also have, as AJ mentioned in his presentation, there's an SDCore controller that runs out here in the cloud. And we also have the provisions for running various APIs that enable our product to be used in an intelligent way. So there are AIML APIs aimed at AIML applications, and there are other enterprise APIs aimed at enterprise applications that might want to exercise control of the network. Now, Aether does support multiple edge sites managed from a central cloud. Each edge site supports multiple radios, multiple slices, and all of these can be managed from that central cloud. So our management platform runs out here, running our runtime operational controller, our metric stack, all of that stuff is running out there. So I'm going to show you quickly the dashboard here. This is the dashboard for one of our operational deployments. This is the Pronto deployment. And Pronto was a grant that ONF has in cooperation with several research universities to run the Aether product at their university. So you can see we have some universities participating here. There's Cornell, Princeton, and a couple of deployments at Stanford. We also have a Tucson office for our company, the ONF Tucson office that participates. And then we also have a couple of other partners. We have Intel and NCTU, not technically part of Pronto, but separated out down here into their own section on the graph. And for each one of these, we're running monitoring continuously of the Aether deployments to show us the uptime, so that we can go back and we can look at this over months or days. We can zoom in and out. And every 3 minutes, we're doing a check of the network to see if it's up or not. And even though this is sort of a pilot program and a research deployment, we're still aiming for high uptime, and we're aiming for multiple nines, which we sometimes achieve, but we sometimes do have issues in development and such that's going on. So that's a kind of the current view of one of our larger deployments. Next, I'm going to start to talk about how some of our service abstractions work. And the purpose of the Aether project is to perform a conceptually simple yet a technically complex task, which is to connect devices to applications. And we recognize that's the primary focus of our customers. That's what they're actually using the product to do, is to get that connectivity. So we tried to make it easy for them. The basic workflow is that an administrator will group his or her devices into groups because it's easier to operate on groups of devices rather than to deal with each device individually. So you can see we've grouped some cell phones here. We've grouped some cameras there. The slice, also referred to as the VCS in some of our current portals. The slice is our abstraction that provides the connectivity. And then on the right side, we have various applications that the devices will use. So slice is really the bridge between the device and the application. And what we tried to do with our high-level abstractions is to take complex 4G and 5G implementation detail and put it in templates and other objects that can be kind of separated from the user experience, so that the administrator does not have to worry about the minutia of configuration details related to that. Now, we also we recognize that analytics are as important, if not more important, than configuration and control. So we have a robust analytics solution based on popular open source tools such as Grafana, Prometheus, and Elasticstack. And you will see a few of our Grafana graphs later in the presentation here. Fundamental to the Aether service abstraction is a set of models. And the models are designed in such a way that key details that are important to the enterprise administrator form the core of the modeling. You can see that in the core here. We've put applications, slices, and device groups, sort of those things you saw in the previous views. Other models exist around the periphery that hold the details necessary to support the core abstraction. For example, you might need to know the set of small cells or radios that are used to support the network. And those radio-related details are out here in a site object. So you see name and a small cell list. Other fields along with the site include some of its parameters that we've assigned to it, such as the MCC, MNC, and enterprise identifier we've assigned to the site. Now, some of these attributes are kind of advanced level attributes. I've kind of tried to color those out here such that things in green are things that a typical administrator might be interested in, where things in orange are things that might come pre-configured by the ONF team when we set up a particular site. We do have the notion of a template, which can be used to instantiate a slice, and the template, it can hold some of those 4G and 5G implementation details that might be things that we do pre-configure. It's not important to understand all of these models to kind of get a feel for the product. And in just a couple of minutes, I'm actually going to go into our live GUI and take a quick look at how some of these models are realized in the actual product. So these models, they are available via a portal, as well as a command line interface and an API. And this is kind of a high-level picture of our architecture. We have two parallel stacks. One of them is the control and configuration stack, which comes down here along this side, and that is where our runtime operational controller is, as well as its API layer. And then over here on the right side, we have our metrics stack, which is primarily composed of Prometheus and Grafana, two very popular open source metrics related tools. Not pictured is the Elastic stack, which handles logging. And then these things present the metric information up, including rendered graphs up into the portals. And then down at the bottom are the various services. So you could think of the SDCore service running down here, the SD Fabric service running down here, and even other infrastructure related services, for example, services that might be managing applications at the edge. We can control it all from our control infrastructure with the ROC. And we do have role-based access control that can be used to isolate users from one another. So next, I'm going to take you through a little bit of the GUI. This is our GUI. When you log in, you kind of start off at a dashboard showing you what's going on. You can see that we have 6 monitoring agents at this particular site, and it's got 4 edge compute nodes. They're all up. But I really wanted to show you some of these models. So going into the VCS model, that is our slice abstraction. And you can see we have 3 slices at this particular site. You can go into a slice. It's easy to set some of the arguments that go along with the slice. For example, the slice has filtering policies, which we'll talk about how those work in a little bit when I describe some of the new features in this release. We have quality of service controls. We have user plane functions. They're all exposed in here, and easy to add new filters, change the QoS. That sort of thing. It can all be configured there from the slice interface. We also have our device groups. You can see on this deployment, we have lots of devices, including, for example, this device group down here that has a bunch of employee cell phones. Going in there, you can see it's pretty easy to go in here and add new devices if you wanted. You just click plus button and you'd type in an identifier for the device and the IMSI. We are planning on some more significant SIM card management features in the future, so that we will get away from the administrator having to directly worry about IMSIs. We'll be managing that ourselves. Be a little bit more of a sort of drag and drop of existing SIM cards into the device groups and slices. But for now, you type in the device name and IMSI, and it would go there. We've also got the applications. So we have lots of applications set up on this deployment. They're each given a name. They've got addresses. There's some other parameters associated with them if you wanted to dive into it. So for example, you could set some QoS related details to the application itself. Just looking at some of our other objects, the site object, that's the one I mentioned in one of the previous slides, that it holds a lot of the slice related details, such as the list of small cells. This particular deployment of Aether only has 1 site in it. That's because this is one of our cutting edge deployments that we're always running the latest version of our software on. So it runs out a little bit ahead of the other production deployments that tend to be more stable. There's also a bunch of those periphery models down here. I'm not going to go into those in detail, but they're easily accessed and configured by the user. We do have API keys. This is where you would go into the GUI and obtain an API key that you could then paste into a terminal session. You could use this with command line tools, and you would be secured and authenticated into the Aether API for performing your operations. And as I mentioned before, we do have role-based access controls. So if I look in here, the system does know who I am. It knows my email, which is my identifier, and it knows what groups I'm in. And the set of groups that really tells what permissions that I have to be doing this stuff on the GUI. So I happen to be in sufficient power user sort of root system administrator groups that I can, as operations team lead, I can pretty much touch anything in here, but other enterprise users would have more restricted permissions than I do. Okay, going back to the slide deck. So you've seen the portal, and the portal sits on top of the API, but that same API could be used verbatim for edge applications, or for controllers for edge applications. And this is how we would 5G enable or add Aether value to some services out there. Our control API is protected by the RBAC and authentication mechanism. We do have the monitoring API that's a little bit more in progress because it's pretty close to Prometheus API at this point. And you'll see in our to-do list that we're going to add an analytics engine for that. But you know, an application can sit up there. It can look at the metrics coming up from the monitoring API, and it can make decisions based on that and change some of those knobs in the GUI. It can do that all automatically. And we will see a concrete example of that near the end of this presentation. Next, I'm going to talk about our release. So we did just have a release. It was either 1.6 release, and it was done mid-December. And it's currently running at our Menlo lab with plans to deploy it out to those Pronto sites. I showed you that it's going to get deployed there pretty much imminently, as well as some other enterprises. The key features of the release are that we now support 3 levels of quality of service, and I'm going to go into each one of these bullet points in the detail slide. So 3 levels of QoS. We support application filtering, user plane functions that may be put in a pool and assigned at runtime, and then single sign-on using Keycloak and LDAP. So the first feature I want to highlight is the support for 3 levels of quality of service using maximum bitrate metering. So this is MBR. GBR is something that is planned for future release as our dedicated bearers. What you're seeing here is currently the default bearers. And you can see in this picture, we have this is a single slice, and it has 3 user equipment. So 3 connected devices. And this particular device here, it has 2 flows. The green flow is going out here to this top application. The blue flow is going down here to this bottom application. So the first one of our meters here is per UE per application, and that's this one that is on the green flow. So we can meter this particular flow from the UE to the green app separately than we meter the blue flow here that's going down to the blue app. That's our first level of QoS. The next one is per UE. So that takes all of the flows from a UE and then meters them together. So both the green and the blue flows are going through this particular meter. And then the third level is the per slice metering. So here you can see we've got both UEs with all of their flows going into this particular meter and being metered to all of their applications. So this really allows the customer to choose, you know, exactly how they want to meter their traffic, at what granularity, and gives you that sort of fine-grained control all the way down to the per UE per application level. The second noteworthy feature is application filtering. So application filtering includes a default behavior together with up to 5 custom rules. This supports either a deny all pattern with rules to explicitly allow certain applications, or an allow all pattern that implicitly allows all traffic, but explicitly denies access to certain applications. So traffic that is denied would be dropped by the UPF. Our rules are always executed in priority order, and the first rule to match determines whether the packet will be passed through or dropped. If no rule matches, then it falls back to the default behavior. The third feature that I wanted to highlight is our user plane functions. So user plane functions are typically provisioned on hardware by ONF at customer onboarding time. So we'll provision a pool of them, you know, like 3 of them or 5 of them or 10 of them, or you know, however many of them we expect the customer will need. But then the customer may assign those UPFs from the pool to new slices at runtime. So this allows the customer to create new slices without having to wait for us to do any resource provisioning on their behalf. If the customer did run out of UPFs, then we can always add more if necessary and enlarge the size of their pool. So next, I'm going to dive into a little bit of a discussion here about a sample enterprise, what it might look like. So the enterprise, I'm going to go through this picture from left to right. The enterprise starts out with some devices. It's got 3 different kinds of devices. It's got some cameras, it's got some IoT sensors, and it's got some phones. And you can see they've been conveniently grouped into those device groups. The enterprise also has 3 small cells placed in 3 different places. So in this example, there's one in the kitchen, one in the conference room, and one in the lobby. And then there's 3 slices. So the cameras, the device group here goes with the camera slice. The IoT sensor device group is in the IoT device. And the phone device group goes with the mobile phone slice. Now, don't think that there's a one-to-one between slice and small cell. They just happen to be depicted this way, but really this camera slice can talk through any of these radios. So, you know, this camera device group can go down here into this radio and then into the camera slice. Each slice does have a dedicated UPF associated with it. That's the dedicated resources for forwarding its packets. And then on the right, we have 3 applications, and you're going to see some of these applications at play when I go to do the demo video. So one of these applications is our OpenVINO camera application. Another one is a pan tilt camera broker. And then another one is a performance server that we use for some of our bandwidth measurements. And then also a possibility is to send the packets out over the internet. So for example, you know, talk to public services like Google DNS, or talk to the monitoring server that we typically use as part of our monitoring infrastructure. Now we went ahead and we realized that sample enterprise network. We used our Menlo facility to do this, and we distributed a bunch of resources around that facility. So you can see we have 3 small cells. There's one here, and one over here. We've got a bunch of IoT devices. Those happen to be based on Raspberry Pis, and you can see there's one here, one here. They're kind of strewn about in various places so that we can get some interesting usage patterns. And then we've also got several cameras. So we've got some of them that use OpenVINO, and some of them that are pan tilt cameras pointed out windows. And you'll see those working in a moment when I do the short demo. And you can see pictures of that here. Here's one of the small cells mounted on a wall. Here's another one. This is an example of the pan tilt camera. And here's an example of one of these simulated IoT devices. So next, I'm going to play a 5-minute demo. And this demo is going to show off some of our cameras operating at Aether. You'll see how our analytics allow you to see slice performance in the dedicated UPFs. And you'll see how we use the Aether API to allow an application to control network parameters. Just let me pause a moment. I want to make sure that I have, I do have sharing optimized for sound. So you should hear sound as soon as I start to play this video. There are several cameras. Some of these are pan tilt cameras, which were constructed by ONF personnel, and other ones were OpenVINO cameras, where ONF has developed a custom AI ML application to demonstrate the edge performance with an AI ML application. Let me go in first, and I will go into the pan tilt camera. It is sitting here at our Menlo office, and it is looking out the window. So I'm going to try to move it to a couple pre-programmed waypoints. I'm just going to send it back and forth several times. So you can see we're generating a lot of video data on it. Let me move it a little bit. You can see it pans relatively responsibly with my cursor movements. And we're currently looking at the servers in the Menlo office. So if we look here, at the graph, we see we have generated some traffic. Now, all of that movement increased the complexity of the video picture, led to more video data being sent. So we bursted from 1 megabit per second up to approximately 2.5 megabits per second. Next up, we're going to demonstrate our AI ML application. Now, the motivation for this application is a security type of proof of concept. Several cameras would be deployed observing a building. And these cameras, much of the time, would be looking at empty rooms because there may not be activity. When these rooms are empty or when there is no activity, these cameras can operate at a lower resolution to conserve network bandwidth. When a person enters a room, the camera should be able to detect the person, classify that that room is now occupied, and switch the camera to a higher quality of video. Now, higher quality of video may generate much more data on the network, so it will be necessary to automatically adjust the maximum bit rate for the camera slice to accommodate that additional traffic. We have our camera. It talks over the Ether network through a small cell, an eNode B, and then through the user plane function, and finally to the person detection application that runs at the edge. When that application detects a person, it uses two APIs simultaneously. One of them is the API back to Ether to tell it to adjust the slice maximum bit rates, and the other is the API that goes back through the UPF, back through the network to the camera to tell the camera to increase its resolution. We can see that our camera slice is set to 7 megabits per second with its maximum bit rate. We can see that we've got about 2.5 megabits per second, probably still some lingering video going on with the pan tilt camera that we were using. Looking in here, let me refresh this. We can see the 3 v1.0 cameras. They're in the common area of the Menlo office. And we can see them looking at various empty rooms. This one here is looking at a teddy bear. The teddy bear is not detected. The application is smart enough to be able to tell the difference between a person and a stationary object. So I'm going to ask Jeremy at this point to walk into the room. And I see Jeremy, he's been picked up on this camera. He's now here at the desk. He's seen at the desk. And the cameras have switched to a higher resolution. And at the same time, we expect this would have been changed from 7 to 10. So let me refresh it and see if that has occurred. So there we can see that it did go up to 10 megabits per second. That was the intelligent control from the v1.0 application. Looking at our statistics, we can see that we did see a slight uptick here in bandwidth as Jeremy started to walk around. We'll see if it goes up anymore. Jeremy, you're still in the picture, I assume?
Yes.
Okay, yeah, there is a nice big bounce from Jeremy in front of that camera. And so Jeremy is in the picture. Jeremy is going to walk out of the picture. Jeremy, can you hear me?
Yep, I'm walking out.
Okay. So Jeremy has left the scene. He's leaving this camera, and then he's out of that one. So we should expect now for the video quality to go back to standard quality. So let me first take a look at the bit rate. We can see that it went down to 7. And there we can also see that the camera quality was reduced back down to standard definition. Okay, that concludes the short video demo. There are several. Here we are. Let's talk about some of the next steps. So every component in ONF has their own individual roadmap, but here are some top-level items from the Aether operations team. We're going to expand on the success of Aether 1.6 by offering additional support for 5G, including guaranteed bit rates and dedicated bearers. We're going to further develop the API that applications can use to control Aether into something we're going to call the application gateway. We're adding a new analytics engine to allow more complex queries and better analytics. And we have a lot of improvements planned for our modeling to include better management of SIM cards and devices, management of inventory, and making our configuration subsystems more scalable and reliable. And I think that takes us to the end of the presentation today. At this point, we're open to answer questions. It looks like most of the questions in the log have been answered. I'll invite, oh, go ahead.
Yeah, so this one seems to be interesting. I'm just reading out the question. How difficult it is to integrate SDCore with the various commercial or open RAN solutions? So one of the things that we would like to tell is that in the DT trial or SDRAN trial in Berlin, we have done that with the disaggregated RAN was able to talk to SDCore, and it's not that difficult. So as I said, we just need a few basic configuration about pointing it to the AMF node and the UPF. That's the minimum config you need, and then you're all set to talk to SDCore. And if you look at the regular G node B or E node B, we have worked out with the 4 to 5 commercial vendors like Sericom, Bicel, then Acceleran, and some of our Aether's enterprise customers, they have connected their own G node Bs or E node Bs to Aether's control plane, right? So it's not that hard, and we have done that in the past. Yeah, and then one more question comes is that like current status of network slicing feature on the SDCore 1.0. I have answered that like yes, SDCore 1.0 and as such Aether is like has a network slicing abstraction available and as a part of 1.6 release of Aether. So you should be able to use the slicing features in the current release. Yeah. There were some couple of questions around the throughput of the base. I have provided the details over the Q&A section. Is that we have tried N3 and N6 interfaces and base is SRIOV based. And please feel free to connect over the Slack, and you can ask a lot more questions, and we may have more of interactive question and answer there. Yeah. Anything you want to take up, Scott, from there?
No, I do see there was a question here about, available tutorials, someone to start using SDCore and Aether. And I think we did record, you saw a 5-minute chunk of demo, but we do have about 20 minutes additional to that demo. And we could, I'll see if we can make that whole thing available. It does take a person more through the through some of the additional steps, adding a device at runtime, that sort of thing. We'll see if we can make that available. We also do have a guide, though I will have to check and look into the availability of the guide. But there is lots of information up there, and yeah, I would encourage you to reach out to us on Slack or via email, and for interested parties, we can talk about the next steps.